and welcome and good morning everybody. I will tell you a little bit about where you are. I'm head of the program for Microstructures and Interfaces in the Fuel Cells and Solid-State Chemistry Division, where Jake is belonging to. Risø was founded in the 1950s as a nuclear research plant, but a lot of things have changed since then, and we are now an institute for sustainable energy, and the vision says that we should contribute to the research and development of sustainable energy technologies, and we should be really leading, at least in Europe, and that we should contribute to an active and dynamic environment of this field. We are indeed not a normal university institute. We focus on strategic research, and that means that we have divisions with topics that are somehow related to themes that are relevant for today's society. And they are changing all the time. It also means that our topics are also changing all the time. Right now, I will give you some examples from our 9 divisions. We have a division for biosystems. They are looking into converting biomass into bioenergy and biomaterials. And examples are, for instance, that they are working with microbial fuel cells where they utilize the wastewater. And they are also working with second-generation biofuels for cars, for instance. So that is something which is very far, I think, from what you're working with. We also have a division working with solar energy. They are particularly into polymer solar cells, and examples here you can see what they look like, and they've just made a nice little lamp which is very easy and cheap to produce and can be used, for instance, in developing countries for giving light for the children to actually do their homework from school during times where there is no one. We also have a very big wind energy division, and they are looking into all related areas with wind energy, meaning metrology, wind turbines, offshore wind, power systems integrations and materials. And we also have testing facilities for windmills. And besides looking very nice, offshore, it's also a very scientific division, and they, for instance, have a 3D model for measuring the wind and the interaction with the wings of windmills, and this is done by laser technology. A complete other topic is fusion energy. Some of you might know about the European project ITER, in France, which is supposed to be the first fusion reactor actually producing energy for the rest of the world. Something like 500 megawatts from fusion. And we also into this project, very exciting. Then there is the Fuel Cells and Solid-State Chemistry Division, where we come from. And we actually work not only with fuel cells, but with all sorts of new energy materials, mostly related to ceramic materials. And we also work very closely together with Danish industry in this area, and we actually produced the first solid oxide fuel cells here and formed the basis for a company there in that area. I will come back to more details about this. Then we have a department or a division that also works with integrating all these different energy systems together. Because one of today's challenges is actually when you have so many types of energy that you actually have a system that can control contributions from these and make a reliable supply. And also, for instance, for finding techniques or projects that can be used also in developing countries, meaning that it's actually reliable and affordable. Then we have a division working on materials research. This is very general research, working on all sorts of properties of different materials. For instance, strong and flexible composite materials for wings for the windmills, or topics as isotopes for medical research or simply just medical treatment. And also, for instance, dating of sediments on the planet Mars, and that is in relation to climate change, so that comes back to the whole topic of sustainable energy and environment. A lot of very different topics, but somehow it still forms something that fits together. At least we think so ourselves. As I said, we're not a very traditional university institute, so we also have a division that takes care of business relations, meaning that they take care of making contacts to industry, taking care of hazarding startup companies, and actually transferring our research out in society. So that is technology transfer. And it's very interesting to work together with them. A few facts and figures. We are at the moment 639 full-time people. About a third of those are scientific staff, a third technical and administrative staffs. We have about 100 PhD students, and all the time about 100 guest scientists and other students coming in and out all the time for different projects. We're using about 620 million Danish kroner per year. Converted into a currency that you're familiar with, this is about 84 million euros or about $103 million. And half of those come from external funding, so we are half governmental and then half, say, external industry funded. And those were the 9 research divisions. To come back to the fuel cells and solid-state chemistry division, you all know the effect and importance of fuel cells, so I'm not going to explain that to you. But you could say we work with the full route from the ceramic processing into materials development, characterization, testing of the fuel cells, and also modeling of those. And I said in the beginning that we work with a lot of different new energy materials related to ceramics, and that means, of course, the solid oxide fuel cells, but indeed also solid oxide electrolysis cells. We also work with magnetic refrigeration because it just happens that this works with the same materials as for the fuel cells. Membranes for oxygen and hydrogen separation, electrochemical flue gas purification, and we've started up a few new topics, that is thermoelectrics and also batteries. And a whole new thing is that, like for the windmills, where we already have a national test center, we will now also make a fuel cell hydrogen technology test center. So industry can come to us for advice with their products and having them approved. So we start out with raw materials, often a lot of powder. Make them into some materials that we would like to do something with, or we're, for instance, making them into cells by TIG casting or other techniques, and making electrodes, or even putting it all together, doing cell tests. And during all this, we often find that things either go wrong or we see effects that we don't understand. And of course, I would say that this all comes down to understanding the microstructure. So this is, of course, very important. And this is a transmission electron microscope image, actually quite old, of the different particles that has formed at the interface between a YZ electrolyte and a nickel YZ anode. And we could relate all this formation of nanoparticles to the degradation mechanism